Oh, okay. All right. Questions. The ones with two triangles. Like number 11. 8 first and then 11.
No, then 12.
Yeah. Tell me what I have here in this triangle. Short side, long side, or hypotenuse? How do you know?
Then it's the shortest one. And it's not.
Mathematically, how do you know? Not just looking at it.
It's not the other one.
So this is, that's right. So this is the short side. I always go from the short side to the others, right? So from short side or short leg, what's the long leg? Times what? Square root of 3, right? Okay, let me put this up here. If this is 60, this is 30, this is x, this is 2x, this is x times the square root of 3. Okay? So, what? Means hypotenuse is always make your way back to the short leg and use that to form the rest of your triangle. What'd you say, 4? 12? 4. I was going to say, I know someone said 4. $60, which means my other angle is what? $30. Do I have the short leg or the long leg? The long leg, and so I need to make my way back to the short leg, yes? So how do I do that? Divide by the square root of 3. So if I've got 5 root 3 and I divide by square root of 3, what does that give me? 5. So this is 5. What's the hypotenuse? 10. What else on your homework? 12. Two? Yes, they were. Not the best at drawing these. Here, this is 60, this is 45, 6 root 3. Okay, we're going to find all the missing sides. That, how do you know? Not equilateral, but isosceles. Isosceles. Base angles are the same, which means the sides are the same. All right, from there. Oh, what? Yeah, square root 2. So this is going to be 6 square root of 6, right? Now let's look at that other triangle. I have the hypotenuse. How do I make my way back to the short side from the hypotenuse? Divide by 2. That's exactly right. Short side is up top because here's my 30. Guys, so here's 3 root 6. Now I need to make my way to the long leg. How do you go from short leg to long leg? I said from short to long. Always a five. $18. All right. Which one shall we do first?
I'll do the one that obviously has
Okay. So 5. So if I divide by square root 2, 8 square root 2 over 2, which is 4 square root of 2. You times it when you go from leg to hypotenuse, but if you're going from hypotenuse to leg, you got to divide. So if I go from, because remember if it's, all right, if these are the same and this is x, this is x times the square root of 2. All right, now up to 30, 60, 90. What leg do I have here? The short one, right? That's convenient because that's the one I need to work from. So from short to long, I multiply by what? Square root of 3. We love you, Solomon. 4 square root of 6. Now to go from, get to the hypotenuse, I need to make my way back to the short leg and double it, right? So 4 root 2 doubled. Still okay? Why? I said we love you. Not from me? You don't feel it? 15. It doesn't work. Sullivan promised she was going to be on her game today and be a different Sullivan. Seven square root of 2 on hypotenuse. That's exactly right. 15. What do you mean it's not right? Says who? If it's a 45, 45, 90 triangle. What? What do you mean it won't? Okay, so right now, all right, look, let's do it. Right now, this is the long leg, right? How do I get from long leg to short leg? Divide by square root of 3. So I'm going to take 7 root 2 divided by square root of 3. 7 root 6 over 3. Now take the short leg. Are y'all done? I'll wait. No, now take Sullivan. Oh my God. Now take the short leg and double it for the hypotenuse. What do you get? 14 root 6 over 3. Absolutely. No, only double the number in front when you double it. Yeah. Anytime you get a CUDA sheet like this, it's a notch up. It always a little harder. A CUDA sheet. See where it says CUDA software up top? It's harder. Yes. The long. Okay, wait. Yes, yes. So you always have to make your way back to the short leg first, and then you use the short leg. No, because there's a zero. It's a zero. All right. All right. Solving triangles. It's really not bad. It's not bad, yeah. All right, we're going to use our calculators for a lot of this. We're going to use trig functions. We're going to use that sine, cosine, and tangent, right, Charlie? Solving triangles. Oh, sorry. All right, so, okay. So solving triangles means we find every single angle and every single side, okay? And so we're going to use several techniques to do that. We'll talk about them. Let me just start. Remember, these are going to be right triangles also. Right triangles because we can use sine, cosine, and tangent when we have a right triangle. But these aren't special, okay? Right. These aren't special. They're not going to be 30, 60, 90, or 45, 45, 90. They're going to be some random other single angle, okay? What? What? Slade, something's been wrong with Slade lately. All sides and angles. Okay. Oh. That's definitely all sides and angles. Solve the triangle. All right, so if I say solve the triangle, you gotta find everything. I'm gonna have to put another one at the top because I am missing an angle. All right, listen. Charlie. How do you know? Those other two have to equal 90 because there's 180 altogether. You've already used up 90. It's right, yeah. Yeah, 180 altogether, yeah. But how are you going to find the other two sides of the triangle? I can't do Pythagorean theorem because I'd have two unknowns, right? A squared plus b squared equals c squared. So what are we going to do? How? Well, this is the new stuff, so let me just tell you. We're going to start at this angle because that's the given one. Always start at what's given because you could have made a mistake just like y'all were hollering out 48, but it was really 58. So start from what's given because you know that's going to be the right angle, right? This side is what in terms of the angle 32 degrees. Okay, but don't think short and long now because it's opposite, right? This is not a special one. It's not a 30, 60, 90. In order to use all the short leg, long leg, all that, it's got to be 30, 60, 90 or 45, 45, 90. This is just a regular old right triangle. And trig works for any right triangle. So here's what I'm going to do. I'm going to think about the trig functions that use opposite. What are they? Sine of theta is opposite over hypotenuse. And what's the other one that uses opposite? Tangent. Opposite over adjacent. Now, before we do this, take out your calculator real quick. Let's all make sure we're doing the right thing, because if you got one of mine, it's definitely not in the right mode. Hit the button that says mode. And listen, before you take, and y'all listen carefully, before you take something like a ACT or SAT or something like that, you probably need to be in radians, so make sure you change this back. We'll be changing back and forth a lot. But go down, the third option down, it says radian or degree, select degree. We'll literally change it back here like in 2 days. All right, second quit and come out. Now, here's why I did that. The sine of 32, notice 32 is in degrees, right? This is just a value. The sine of 32 equals opposite, which is 11, over hypotenuse. I'm going to call this hypotenuse x. And watch what... All right, because this, I'm trying to find a missing side, right? And sine will relate the opposite side to the hypotenuse side. So since I have one of them and I know the angle, hit sine 32 on your calculator. Know what you got? Can you solve that for x now? Do it. $11 divided by sine 32, yeah. You could do 11 divided by the sine of 32. If I'm solving this, I'm going to multiply both sides by x and then divide. That's just how I see it best. I'd take it step by step like that. Move. I'm going to do a little approximately because this is not an exact answer, right? I'm going to have to round it off. And I'm going to round it, I'm going to say 20.76. You got what? That's no fun. Now can you find the other side? Yes, how? I could do Pythagorean theorem, or I could do another trig function if I wanted to. I could maybe do tangent on this to find the other one. Same process, the same way of going back. I tend to do Pythagorean theorem. A squared plus 11 squared equals 20.76 squared. If I square that, if I subtract 121 and then I take the square root, I got approximately 17.60. Now my triangle's solved. I have all three sides and all three angles. Does that make sense? Okay. That's wrong? No, it's not. I might have been around here. I didn't round off in my calculator. And then it's the square root of that. It just depends. So look at what you've given. So everything written in black is what I was given, right? So I need to use one that's got the opposite side on it. So that's why I said sine or tangent. Either one would work. If you did tangent, it would have given you this side first, and then you'd have to go in and find the hypotenuse using Pythagorean theorem. So it just depends on whichever one you want. Yeah. Yes, why? That's what they were just asking. So you look at the theta that you were given, right? Like, let me show you this one. What is it? 26? But how do I know which trig function to use to find the missing sides here? So I'm going to look at the angle that was given. I'm going to let this be my theta because that was given to me, right? I know I didn't make a mistake adding or subtracting on that. So my theta is going to be 64. So in relation to 64, do I have the opposite hypotenuse or adjacent? I have the adjacent side, right? Use the angle that's given for your theta. So the 64 is what we started with. Yeah. No, we figured that out. Yeah. It's not wrong if you use 26. It's just changing where you're going with it. All right. So which trig functions deal with the adjacent side? Tangent. I know tangent theta is opposite over adjacent. Which other one? Cosine. Cosine of theta is adjacent over hypotenuse, right? Pick whichever one you want. It doesn't matter. We'll go tangent this time since we went with the other last time. The tangent of 64, and it matters where you're starting, right? I'm starting here, so now opposite, that's the one I don't know, right? I'm going to call it x. Over adjacent, which is 3. So I would probably take out my calculator and just do 3 tan 64 to find out what x is. That's x. Yeah, that's fine. Now Pythagorean theorem to find the missing side. All right, let me show you one more thing and I'll be done. What happens? No angle. You're going to have to find it. And I'm going to show you. This is easy. All right, the missing side's easy, yes? I'm just going to do Pythagorean theorem. 6 squared plus whatever that is squared equals 15 squared. Oh my goodness, I thought we were fixing to leave. I forgot it's 50. I was starting to stress. All right, so square root of 261 About 16.16. Oh no, I messed up. 15 squared minus 6 squared. Hey, 13 point. What? What are you talking about right now? Right? What? Is that what y'all talking about? No, you can't sleep and get points. Yeah. $13.75. All right, now here's what I'm gonna do. All right. How am I gonna find the missing angles? Here's what I'm gonna do. Pick an angle to start from. Either one you want. Not the 90 degree, obviously that doesn't work. Okay, this one. I'm gonna call that theta. Okay. Look, pick whichever one you want. Okay. Pick one. Just pick. It don't matter. Yes. Yeah, no. You want to guess again, or you want me to tell you? I'm gonna go with you're gonna use a trig function since we've been doing that this whole unit. Huh? So, what sides? Tell me if I'm letting this be my theta. Tell me what sides I have. Opposite and hypotenuse. Tell me which trig function deals strictly with opposite and hypotenuse. Sine, right? Sine. SOHCAHTOA, right? So the sine of theta, TOA. You do, but I never use one that I calculated just in case I made a mistake in my calculations. All right, the sine of theta is going to equal opposite over hypotenuse, okay? Now, here's the question. How do I solve this for theta, okay? And this is really easy. If you look at your calculator, look at the sine, cosine, and tangent on your calculator. You see right above it, it says sine -1, cosine -1, tangent. All right, those are inverses. Inverses are going to cancel it out. So what I do, you know how if you do the same thing to both sides, it cancels out? To get rid of this, I need to do it by an inverse, okay? And if I do it to that side, I have to do it to this side as well. So theta is going to be the inverse sine of 6 over 15. So if you take out your calculator and do second sine, 6 divided by 15, it will give you, there you go, about 23.6 degrees. Now I can find the last angle. That's right. Yep. You got it right. See, these aren't hard. I almost skipped over this assuming you had it in geometry, and I was like, nah, because we're going to just use 30, 60, 90, and 45, 45, 90 on the